Hey y'all, I'm Elijah and this is my Lab 1 report for Physics 2. In this lab, I explored how charged pieces of tape interact with each other. I modeled this using both a point charge approximation and a more realistic line of charges model using GlowScript. The goal was to estimate the magnitude and sign of charge on a piece of floating tape by analyzing its behavior experimentally and confirming it with code. I used Coulomb's law to model the electrostatic force and Newton's second law to relate that to gravity. In the experiment, I suspended one tape above another and adjusted their positions until the top tape floated, meaning the electric force matched the weight. I measured the dimensions and mass to use in my calculations. In the point charge model, I used Coulomb's law and solved for Q. This gave me about 1.42 nanocoulombs of charge, which translated to about 8.95 billion electrons lost. This visualization shows the upward electric force as the orange arrow and the downward gravitational force as the green arrow on the top tape. They're balanced, which confirms the tape would float at that charge. So to improve realism, I modeled each tape as a line of charges. I used the electric field function from Lab 0 to compute the field at each segment of the top tape from all segments of the bottom tape. And here you can see my GlowScript code that I used. Yeah. Okay, so then after adjusting the charge value, I found that at 6.01 times 10 to the negative 8th coulombs, the net electric force on the top tape was 4.703 times 10 to the negative 3rd newtons, which nearly perfectly balances the gravitational force of 4.709 times 10 to the negative 3 newtons. That means that this charge is accurate in our model. Yeah. Okay, so then for the point versus line model comparison, the point charge model gave a much lower Q because it concentrated all the charge at a single point. The line model spreads charge evenly, not evenly. The line model spreads charge along the tape, so it needed more total charge to float the same distance. So here's what if and why. So the first one is what if electrons were positive and interactions would still behave the same, but the labels would flip? And then why is line Q lower than point Q? Is because the line model again spreads charge, so less is needed to create the same field effect. And if electrons were positive instead of negative, the behavior wouldn't change. Attractive and repulsive forces still occur. The reason the line model needs more charge is that the force from each piece is weaker when spread out, so it takes more total charge to lift the tape. So, in conclusion, this lab showed how electrostatics can be applied to real objects like tape. I verified the charge experimentally, then confirmed it using two computational models. The line charge version gave a realistic value and perfectly balanced gravity, which confirms that my modeling was successful. So, thank you for watching this and have a great